So we looked at it doing trig, and that's where you have to do your vectors and you come up with your total triangle, and then from there you can solve your answers. We're going to look at it using the sine and cosine laws. Do you guys remember that part? So you have your triangle of capital A, B, C, and then you have your side lengths that are little a, B, C.
What?
Kind of, sort of.
Can you say that again? I'm sorry, I zoned out.
That's a constant state for you.
As of this point, yeah.
Okay, so I'm going to reintroduce the cosine law to you guys, and then we're going to solve the problem. So remember when you have, I'll just write it over here. When you have your triangle like this, and you have A, and this is A, this is B, this is C. Do you remember that?
Yeah.
Okay, this is where we're going, is with this.
That's about, there's more to it, but I
Well, there
forget.
is. There's B over the sine of B.
Oh yeah, then
Is equal to C over the sine of C. Equal to A over the sine of A.
And then
right?
what's cos?
We look mostly at sine. Okay. Is it on the formula sheet? Look at that. Okay.
This is actually useful. Whoa.
Is this the one we're doing?
Ah,
This is not the one
yes.
we're
A squared plus B
This
squared
one here
minus
we're doing.
2AB cos C equals cos C.
Uh-huh.
Okay.
Okay, so same kind of question. A 4 kilogram object is moving at unknown velocity when it collides with a 6.1 kilogram stationary object. After the collision, the 6.1 kilogram object is traveling at a velocity of 2.8 meters per second, 32 degrees north of east, and the 4 kilogram object is traveling at a velocity of 1.5 meters per second, 41 degrees south of east. What was the velocity of the 4 kilogram object before the collision? So, it's the same. It's the same question. Always set it up so you're knowing what you're doing. So we had cart 1 and cart 2. And we're looking for the velocity before of the 4 kilogram object. This is 6.1 kilograms. Oh, my smartboard's out. And it collides with a 6 kilogram stationary object. After the collision, the 6.1 kilogram object is traveling at a velocity of 2.8 meters per second, 32 degrees north of east, and the 4 kilogram object is traveling at a velocity of 1.5 meters per second, 41 degrees. So, south of east is going to be this way. And so this angle here is 41 degrees. And he's traveling at 1.5 meters per second, and this is 4.0 kilograms. The 6.1 kilogram object is going 32 degrees north of east. That's your 32, 6.1 kilograms, and he's going 2.8 meters per second. Remembering this time that the vectors are meters per second and not momentum. Okay? So what we need to look for and what we can solve is, we can't solve momentum 1 here, but we can solve momentum 2 here as being 0, because mass times velocity, anything times 0 is 0. Here we could solve our P prime. So 1.5 times 4 equals
6.
6. Oh, it's not per meters per second. And then the other one here, P2 prime. P2 prime equals
17.08.
okay. Okay, and that's these values here. That's your actual angled one, your hypotenuse. So this is 6.0 kilograms meters per second, and this one is 17.08. If we're putting in our information. Now how it works with sine and cosine laws is we have to create a triangle. Okay? So we have one that's going 32 degrees, one that's going 32 degrees, and we have one that's going 41 degrees. So this one is 6.0 kilograms meters per second. And this one is 17.08. And then we have our okay. So this angle here if we were to make this a right angle triangle, this angle there is 32 degrees. Okay? And this angle here is 41 degrees. Now what do we know when we're looking at these angles? What can we do? What can we say? If this angle here is 32 degrees, hello, we're doing sine and cosine laws.
I should remember that.
It's a bit of a stretch, but we're doing good. Okay, what can we do with these pieces of angle information? What can we do? What can we say? If this angle here is 32 degrees,
The one on the other side.
the one on the other side over here
32.
is 32 degrees.
And then 180 minus 32 is
Wait, we're not done. We can put in one more.
the 148. And then you minus your 41. And then you get your big angle up top.
Right. So our big angle here then, Jaden,
It's 107.
is 107.
And then 32.
180 minus 32 minus 41 equals 107.
Then you add your 32 to your 107. And then 180, 139. And then
I'm good with the 107.
Whoa.
Okay.
Means that our angle over there.
So this one here is P2 prime. This one here is P1 prime. And so we have a lot of information. This is where we need to really pay attention to what's going on. This is A, this is B, and this is C. And we know that P total before is equal to P total prime after.
What I'm like, I know what we're doing, but like, what are we trying to find? Like, I know we're trying to find velocity before,
Yeah.
but like, how does making this triangle of using our P primes
Because we don't have P total prime, we only have,
and P total is that stretch that we don't know,
Right.
that's C?
right,
Oh.
okay? So what we're going to figure out first is this part here is what we're figuring out, right? this angle here is going to be our angle of concern.
Yeah, you can have your article by the end of the day, that's perfect.
Okay, and this dotted line here on the bottom is our P total prime. So we can start with figuring out this step 1. So C squared is equal to, when you look at your formula sheet in your data booklet, what does it tell you?
What?
C squared is equal to
A squared plus B squared minus 2AB cos theta. Oh, cos C.
AB, sorry. Okay, so we have our angle C, we have our momentum on A, we have our momentum on B, so we can go ahead and finish this off, right? So C squared is equal to 17.08 squared plus 6.0 squared plus, subtract 2 times 17.08 times 6.0 times the cos of 107 degrees.
3. I don't know about this. Oh, and then square root together.
Start with C squared. What did you get?
387.65.
I'm guessing a lot of right answers.
And what's our units, Jaden?
Kilogram meter second.
So C is equal to, this would be squared.
19.468885.229.
So that's our side length C. That's our P total prime. And because P total prime is equal to P total, we can figure out the velocity, or the speed, it's just looking for speed, no, it's looking for velocity of the 4 kilogram object before. So oops. Not M1. And you will have kept your decimals all the way along. VI equals
4.92. Yeah.
okay, so it's velocity, so what other component do we need to do?
Direction.
The direction. So we're going to continue on with the sine part of it. We are looking for this angle here, capital B, and we have this angle here, C, so we're going to use B over sine B is equal to C over sine B.
Sine C.
Sine C, thank you. Need to restart today, I think. Oops. Okay, so to find out the angle of B, you need to take the inverse of sine of the math inside the brackets. So the math inside the brackets is 6.0 times the sine of 107 divided by 19.688, and you take the inverse sine of that, and you get
16.94.
okay. What we need to remember though is this part here, that the 32 degrees is all of this. So we have to go 32 degrees minus 16.9433 degrees. And we get,
Why are we doing that?
Yeah, that is not what I think that was.
Yeah, you're trying to.
You have your inset for this part of the triangle.
Yes.
That's finding the part that's between the angle and
16.94.
yeah, but this part here, sorry, it's this part here that we want. This is the horizon right here,
yeah.
right? And this is wrong. This is the angle of concern right here. This one in here.
Because,
Why would
Cameron, our answer is this line here.
What we found was this inside angle, Cameron. We found this inside angle right here, and we want it from the horizon.
Because, like,
oh, okay.
Okay? I initially told you that that was the angle we wanted, but we actually want this outside angle to the horizon. Okay?
and we, like, I think I got it. I don't know how to explain it to ask you if I got it, so I'm just going to go with I got it.
This angle here is to the horizon, which is what we're looking for. The angle to the horizon.
Yeah, we're using that because C is our answer, which is equal to.
Yeah,
Yeah. Okay, I know what I'm talking.
sort of.
A little bit.
So 15 degrees, when we round it up. So our answer then in actual sig digs is
15 degrees.
total answer.
15.056.
No.
Oh.
The whole answer. The
Oh.
answer was what is the velocity of the 4 kilogram mass?
We could do like 1.9 times 10 to the 1.
4.9 meters per second, 15 degrees
Oh.
north of east. You got it, but you don't quite got it.
I knew my
Does
life
that
was
make
gonna-
sense? Other than this part here where I was wrong? This part here is the angle of concern?
Yeah.
Okay.
I knew my luck was gonna run out at some point. I was like, too much is going right today.
Okay, I'm going to give you guys about 5 minutes to try this one using trig. The answer's there, but you have to be able to show your work.
Oh, I thought you wanted us to
Okay.
find the answer. I was like, we got it.
No, I want to see your work.
Oh,